Hello friends, welcome to Tom Science. This is problem number 4, performance of boiler evaluation using direct method, module 7. In this problem, we will discuss how to calculate the percentage of heat utilized by economizer, superheater and evaporator. Also, we will discuss how to find out the overall efficiency of the boiler. Now, we will discuss problem. The following particulars refers to a steam power plant consisting of a boiler, economizer and a superheater. Steam pressure is 11.5 bar. Mass of steam generated is 6000 kg per hour. Mass of coal used is 700 kg per hour. Calorific value of fuel is 32,000 kilojoule per kg. The temperature of feed water entering the economizer is 25 degrees Celsius. Temperature of feed water leaving the economizer is 150 degrees Celsius. Drainage fraction of steam leaving the boiler is 0.95. The temperature of steam leaving the superheater is 350 degrees Celsius. Determine the overall efficiency of the plant. Percentage of heat available in boiler, economizer and superheater. First we will discuss about boiler. Here we have boiler. In boiler we are having economizer, superheater and evaporator. Remember, initially the water enters into economizer where it absorbs heat from the waste flue gas which is coming from the boiler and increase temperature of the inlet water. That's why we call economizer. The outlet temperature of the economizer will be higher than the inlet temperature of the economizer. After economizer, the water enters into evaporator. Remember this. Now in question, the temperature of feed water entering the economizer is 25 degrees Celsius and leaving the economizer is 150 degrees Celsius. This 150 degrees Celsius water enters into evaporator 150 degrees Celsius and is come out from the evaporator 11.5 bar and a drainage fraction of 0.95. After evaporator, the steam enters into superheater where it is heated further and increase the enthalpy of steam. The outlet of the superheater is 350 degree Celsius and 11.5 bar. For this case, we need to find out what is the saturated enthalpy at 25 degrees Celsius at 150 degrees Celsius, saturated liquid enthalpy. Here we need to find out what is our waste steam using formula enthalpy of waste steam. Here enthalpy of superheated steam. First we will find out the overall efficiency of the plant, that is output divided by input. For this we can find out what is the efficiency of the boiler. The amount of fuel given to the boiler is mf into Cv. So the formula is the amount of steam generated divided by heat supplied. What is steam generated? Mass of steam generated, that is 6000 kg per hour. The enthalpy of outlet and enthalpy of inlet. This is 25 degrees Celsius. This is 350 and 11.5 bar. Divided by the amount of heat supplied is mf into Cv. Already we discussed this ms divided by mf can be taken as evaporation. This equation can be written as MAHS minus HF divided by Cv. Now we find out what is our HS and HF. To find out enthalpy of the boiler, which is coming out 11.5 bar and 350 degrees Celsius. We can take from the steam table or we can use the formula. Here we are going to use formula alone, that is 11.5 bar. Let's take what is our saturated temperature, that is 186 and the enthalpy is 2781.3. 3. Take the 2781.3 and saturated 186. Use formula H is equal to Hg plus Cp T superheated minus T saturated. Cp let's take 2.1 if they are not given in question, and find out enthalpy, that is 3125.7 kilojoule per kg. This is enthalpy after superheater. And now the inlet is 25 degrees Celsius. We know that. For that we can take the saturated enthalpy, that is 104.9 kilojoule per kg. Let's substitute and find out the efficiency of the boiler, overall efficiency of the boiler, that is 8.57. This ratio, that is 6000 divided by 7000 will come 8.57. The enthalpy of steam 3125.7 minus 104.9 divided by calorific value. The efficiency of the boiler is 80.9%. Now we will discuss the percentage of heat available in economizer, evaporator and superheater. First we are going to discuss about economizer. We know the inlet of the economizer is 25 degrees Celsius. The outlet is 150 degree Celsius. To find out percentage of heat utilized, first we need to know how much heat is available between 25 degrees Celsius to 150 degrees Celsius, that is mass of steam generated. It is denoted as Qu is equal to Ma. This is mass of steam divided by mass of fuel. We are taking per kg of fuel. The enthalpy outlet of economizer minus enthalpy at inlet of the economizer. We found out what is our HF2 and HF1. We know the HF2 is 150 degrees Celsius, HF1 25 degrees Celsius. For this 104.9, we know from steam table 25 104.9 kilojoule per kg. Similarly, for 150 degrees Celsius, we can take our steam condition is with enthalpy here we have, that is 632.2 kilojoule per kg. For this, we can find out, substitute 8.57 is ms divided by mf, enthalpy of outlet, enthalpy of inlet, and QE becomes 4518.96 kilojoule of energy per kg of fuel. Very, very important because we are using MA here. How much energy is available to us? Totally 32,000 kilojoule energy is available per kg of fuel. Here also per kg of fuel. So to find out percentage of heat utilized, QE divided by CV, the percentage if you see, that is 14.12 percentage in economizer. This is the percentage of heat utilized in the economizer. Next we will discuss about evaporator. Here we have where inlet is 150 degrees Celsius and outlet 11.5 bar and dryness fraction 0.97 wet steam. Again, to find out the percentage of heat utilized, first we need to know how much heat is available in evaporator, that is denoted as QB. B is known as boiler, is equal to Ma. This one we are taking H and this one we are taking HF2. This is not 1, HF2. Find out HF2, that is 150 degrees Celsius. Already we found out, that is 632.2 kilojoule per kg. Now to find out H, we have 11.5 bar. Take for 11.5 bar our HF and HFG, that is 789.9 kilojoule per kg. Similarly 1991.3 kilojoule per kg. Use formula H is equal to HF plus X HFG. This one taken from the steam table. This one also taken from steam table. X value given in question, that is 0.95 and H becomes 2681.64 kilojoule per kg. Substitute, that is 8.57, 2681.64 minus 632.2. QB becomes 17563.7 kilojoule of energy per kg of fuel. This much energy is needed to develop 150 to 11.5.97 steam. For total available 32,000. So percentage of heat available in evaporator, QB divided by CV. So percentage 54.89 percentage heat is utilized in the evaporator. Next one we will discuss about superheater. The inlet of the superheater is 11.5 bar and 0.95 dryness fraction, and the outlet is 11.5 bar and 350 degree Celsius. To find out the percentage of heat utilized in superheater, we need to find out amount of heat available in superheater. That is, this one we take HS, this one we take H. It is denoted as QS is equal to MA HS minus H. Both we found out already. That is, HS is equal to 3125.7 kilojoule per kg. We found out where we need to find out the overall efficiency of the boiler, and similarly H we found out in last slide, that is 2681.64 kilojoule per kg. Substitute, that is 8.57, 3125.7 minus 2681.64. QS becomes 3805.59 kilojoule per kg of fuel. How much we have? We have 32,000. So the percentage of heat utilized in superheater, QS divided by calorific value, it becomes 11.89 percentage. If we add QB, QS and QE and subtract its total energy, that is 32,000 or 100 percentage, we get what is the overall efficiency of the boiler, that is 80.9 percentage. In next lecture, we will discuss how to find out the performance evaluation of boiler using indirect method. If you like this video, kindly like, share to your friends. If you have any doubt, kindly give in comment box. I will reply to you. Please don't forget to subscribe our channel. Thank you.